there's nowhere else for it to go. But we have talked about like combinations of things a little bit before in this unit. So the first question asks us how many different outfits can we make if you have 3 pairs of pants and 2 shirts. And so when we were talking about combinations before, like to figure out the total, we just like multiplied the numbers. So if we have 3 pairs of pants, 2 shirts, we would just do 3 times 2, which would give us 6 combinations total. 3 times 2 is 6. Same thing with the second one. If you have 4 sandwich cookies, 3 side choices, 4 dessert choices, we want to know how many different meals can we make. We just multiply all the numbers together. So we do 4 times 3 times 4, which is 48. All right, so these previous problems use what's called the fundamental counting principle. It's just a way of like multiply instead of like making out a list. Instead of like listing out the 3 pants and the 2 shirts, we can just multiply the numbers. We do this because like if we have like a longer list, so like for this next problem, if you're talking about license plate, so for license plates there are 3 letters and 3 digits. So in total there are like 6 different spots in a license plate. So there's like 1, 2, 3, 4, 5, 6 spots in our license plate, right? 3 letters, 3 numbers. So the first, let's just say the first 3 are the letters. So for each spot, how many options do we have? How many letters are in the alphabet?
26 plus 9.
26 letters in the alphabet. So for each letter spot, we have 26 different letters it could be, right? For the first spot could be A through Z. Second spot could be A through Z. Third spot could be A through Z. So we have 26 different options for 3 of those spots. All right, and then we're going to say the last 3 spots, those are the number spots. So obviously it's going to be 1-digit numbers because it's 1 spot. So it's going to be any number from 0 to 9, which is 10 different options, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different options. So we have 10 different options for the number spots. So this one would be like way too long to write out all of these different combinations. So we just multiply all the numbers together. So we're going to do 26 times 26 times 26 times 10 times 10 times 10. That's going to be a super big number. Should be 17,576,000. All right, so the first thing we're going to talk about today is called a permutation. A permutation is an arrangement of items in a particular order. So the order matters in this case. So it matters what order we're putting the items in. So for this example, we're going to make a list, and then I'm going to show you the shortcut. So it says, suppose we want to find the number of ways to list our letters A, B, C. So just like different order of the letters. So the first one obviously would be A, B, then C. What would be another one we could do?
EAC.
EAC. Right. What else? Cab, C-A-B, Cody. Give another one. ACB. There's 2 more. CBA. There's 1 more. BCA. Okay. So there are 6 possibilities or ways, either one, for us to list ABC. So we can find the different ways with this shortcut that's called a factorial. So you're going to see this factorial, write down this like formula right here, and then you don't have to write down both examples. You can just write down 4 or the 9. But you're going to see it as a number and then this little exclamation point. So that exclamation point means factorial. All right, so just to show you how like the little formula relates to this example. So if it's we're doing some number factorial n, we take that number, so in this case it's a 4, and we just multiply it until we get down to 1. So we do the first number n, which is 4, and then we multiply that by n minus 1. So that's like 4 minus 1, which is the 3. And then we do n minus 2, which is the 2, and then we keep going, until we get to the number 1. Why do you think we don't want to go all the way to 0? Right, because then you would kind of just undo what you did and just make it 0. So we multiply all the numbers less than the number we're taking the factorial of until we get down to 1. So for like the last one, ABC, we were trying to rearrange this into however many ways we could, and we found it was 6 ways once we made the list. So we had 3 things that we were arranging, so we could do 3 factorial, which would be 3 times 2 times 1, which is indeed 6. So instead of having to do a list, we can just do the factorial. So like on the next one, it asks how many ways can we file 12 folders in a drawer? We would do 12 factorial. Which would be 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. All right, you should get 479,001,600. That should be what you're getting. All right, and then so the next one, how many ways can we arrange 8 shirts? We want 8 factorial. So 8, 7, 6, 5, 4, 3, 2, 1. And if you're doing it by hand, like I would break it up into chunks maybe, like do the first 2, second 2. Like do it like that. That way, I don't know. You could kind of chunk it. That'd be easier. And this one is 40,320. Like I said, we're not going to be like doing literally just the factorials. We're going to use it in a formula in just a second. We just have to introduce this idea of how to use factorial. All right, so okay, so sorry about that. I don't know what happened. Okay, so like I was saying, we do n factorial in the top, divide by n minus r factorial. R can never be bigger than n or less than 0. So if we have 10 students in a race, first, second, and third places will win medals. We want to figure out how many different ways can the 10 runners finish first, second, and third. So the order matters in this case because it matters who's getting first, second, and third, right? So what we're arranging is the 10 runners. So that's going to be our n in this case, and it's a permutation because our order matters. And then we're arranging them in first, second, and third, so 3 ways. So my r will be 3. And again, r could never be bigger than n, so if you had it like 3 permutation 10, that wouldn't make sense because you can't arrange 3 things in 10 different ways. So it always has to be bigger number first and then the smaller number. So it's going to be 10 factorial, and then it's 10 minus 3 factorial in the denominator. So then we can simplify that 10 minus 3. We can make that 10 factorial over 7 factorial. Now, like I said, we're not going to have to do all this crazy multiplication. I'm going to show you what happens. We can cancel things out. So I'm going to write this one out all the way, just so you can see, and I'm not going to write the rest of them out. But 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And then 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. So this is a fraction, and we could like simplify the fraction. So whatever they have in common can cancel out in the numerator and the denominator. So the 7, the 6, the 5, the 4s, the 3s, the 2s, and the 1s. So all we would be actually have to multiply is 10 times 9 times 8. So whatever your factorial is in the bottom will cancel out all of the numbers in the top less than that number. So 10 factorial on the top divided by 7 factorial, all the numbers less than 7 will cancel, and you'll just be left with a 10, 9, 8. So we don't have to do all that long multiplication, really. And you multiply that, you should get 720. Alright, so next one, this one is same idea. We have 15 runners getting in first, second, and third. So the order matters because we're putting them in different places. So my n would be 15. Permutation r would be 3 because we have first, second, and third. So the numerator is 15 factorial, and then we're dividing by 15 minus 3 factorial. So it's going to be 15 factorial. 15 minus 3 would be 12 factorial. Cody. So for this one, all the numbers less than 12 and less will cancel. So like in the top we have 15 times 14 times 13 times 12 times 11 times, keep going. And the bottom we have 12 times 11 times, that keeps going. So all those numbers, 12 and 11 and below, will cancel, and all we would have to multiply is 15 times 14 times 13. Which is 2,730. All right, so permutation order does matter. Combination is where order doesn't matter. So we're still doing in items chosen r items at a time. Here's your formula for combination. Write it down and then I'll talk about it. All right, so this one's pretty much the same as the permutation formula. There's only one difference, is that we have an extra r factorial in the bottom. So we still do n factorial, we divide by n minus r factorial, but then we have the extra r factorial in there. So for this one, they say, what's the combination of 13 items taken 4 at a time? So we want 13 combination 4, right? N is always bigger than r. And so we're going to do 13 factorial in the top, and then this one has the extra r factorial. So we want 4 factorial in the front, and then we also do 13 minus 4 factorial in the bottom. So in the top we have 13 factorial. Now I have a 4 factorial and a 9 factorial in my denominator. So not everything will cancel in this case. We'll still have stuff in our denominator that we have to divide by. So in the top, I'll have 13 times 12 times 11 times 10 times 9 times 8 times, keeps going. And at the bottom I have my 4 factorial, so 4 times 3 times 2 times 1. And that's multiplied by 9 factorial, so 9 times 8 times 7 times, keeps going. So you want to cancel out the bigger factorial, because you want to cancel out the most numbers that you can. So always cancel out the bigger one that's in the bottom, so in this case the 9 factorial. So anything 9 and less can cancel from the 9 factorial and the top of our fraction. So then I'll only be left with 13 times 12 times 11 times 10, and we're going to divide that by 4 times 3 times 2 times 1. Which should give you 17,160 divided by 21. Sorry. 24. Yeah. My bad. Which is 715. Alright, so I want you to try the next two. Alright, so number 9 it'll be 8 factorial over 3 factorial times 8 minus 3 factorial. So 8 factorial over 3 times 5 factorial. So what's going to cancel is, try to cancel the biggest one. So it'll be 8 times 7 times 6. So I'm going to cancel everything less than 5 and just have the 3 factorial. So 3 times 2 times 1 in the bottom. So it should be 336 divided by 6, and you should get 56 for that one. Alright, the next one, 9 factorial 2. So we have 9 combination 2. So then we have 9 factorial, 2 factorial, 9 minus 2 factorial. So we'll have 9 factorial over 2 factorial, 7 factorial. So cancel the 7 out, so you have just 9 times 8, and then that's over 2 times 1 in the bottom. So 72 divided by 2, which would be 36. Alright, questions on any of these? Okay. So I'm not going to tell you which one to use. So these are the kinds of problems usually that you're going to encounter. Like you have to figure out, does order matter? Should I use permutation? Should I use combination? So this one says a chemistry teacher divides her class into 8 groups. Each group submits one drawing of the molecular structure of water. He will select 4 of the drawings to display. In how many different ways can he select the drawings? So do we think that order matters in this case?
No.
Why do you say no?
Because it doesn't.
Because it's just random drawings. Like, it doesn't matter who we draw or what order we draw them in. They're just random. So is this a permutation or a combination? Combination, because order doesn't matter with combination. So we're going to do the combination formula. What's my N in this case? 8, right? We're picking from 8 groups. Combination, what's my R? 4. Picking 4 from the 8 groups. So we want to do N factorial, so 8 factorial. Combination has the extra R factorial on the bottom, so we want 4 factorial, 8 minus 4 factorial. So that'll leave us with 8 factorial over 4 factorial, which would be, they're both 4s, so it doesn't matter which one we cancel. So it's going to be 8 times 7 times 6 times 5. Cancel out one of the 4s, so we have 4 times 3 times 2 times 1 in the bottom. So it'll be 1680 over 24, which equals 70. So 70 different ways that this chemistry teacher can select the drawings. All right, so the next one says you will draw winners from the total of 25 tickets in a raffle. The first ticket wins $100, second ticket wins $50, and third wins $10. And how many different ways can you draw the winning tickets? So does order matter in this one? Yeah, why? Yeah, because it matters what place you get in because you get different amount of money for each place. So this one is a permutation or a combination? Permutation. So we're going to use permutation formula. What's my in this case? 25. We have 25 raffle tickets we're taking from. We're doing permutation. And then what's my R? Right, 3. We have first, second, third. Don't let the money throw you off. We're choosing those 25 tickets in first, second, and third place. So then it'll be 25 factorial over, and the permutation doesn't have the extra R in the bottom, so it's just going to be 25 minus 3 factorial. So it's 25 factorial over 22 factorial. So the 22, everything less than 22 will cancel, so it'll just be 25 times 24 times 23. Which is 13,800.